3D chess project that we had done. And this was a 2-week project that we implemented into mathematics and the computer science classes in year 7. Before, a few weeks ago, they were learning about kind of the theory of 3D printing in their computer science classes. And then in mathematics, they were also learning about kind of 3-dimensional space and 3-dimensional solids. And we thought, what better way to integrate those two concepts together? And they really got to get a sense of the real thing, the 3D printer working in action, like how to prepare that 3D solid. This lab is really a place for students to be able to utilize the tools here, whether it's 3D printing or laser cutting or just using circuitry, but it's really a place that I like to consider a free place, a free space for them to just openly be able to experiment, tinker, right? Tinker with the products.
The project requirements were for the shape to be 4 by 4 centimeters each. Each shape had their own unique features that needed to be specifically modeled out.
When we were trying to do the project, we actually made a mistake in the 4 by 4 centimeter square and all the calculations. We were downsized by 10. So when we tried putting it into the 3D rendering app, it was extremely tiny. So then we went back and fixed it. We realized what we were doing wrong. And now we've upped the measurements to the perfect length and width and height.
3D designing our piece, we had to consider the fact that we would need support material if we would use maybe over-complicated structures with unnecessary curves, which doesn't really improve the structure, but on the other side make it worse, because it would be easier to break. As well as we had to consider that the chess piece had to be understandable, that it represents the particular figure. Otherwise, it wouldn't be recognizable and we wouldn't see it, for example, the rook as a bishop.
Well, after we transported it to the Ultimate Kira software, we went through all the layers and all the renders of it, and we could see each individual layer of our chess piece. We had to wait a bit of time for it to render, but then we got to see the making of the print itself digitally in a simulation.
We're two different people, but we kind of like merged our creativity and ideas together, and I think we did a pretty amazing chess piece.
I enjoyed it a lot. There were a few challenges, but overall it was a really fun experience, and we're really lucky that we get to experience this.
We played chess on Thursday. We used the app Chess Kid, and we did some lessons out of 30, and then we played against each other. And Chess Kid is a really nice app. And we also played with our friends after that to compete to earn stars, and we had a fun time.
I played with bots of different levels, and then I challenged other students in my classroom. We watched a video at the beginning where they showed us how each piece moves and how they move it and what they do.
3D printing will affect the future in a better way.
So I think 3D printing will give access to the unfortunate people for housing. For example, also prosthetic limbs.
We won't buy physical objects. We'll get sent a file, which then we send to our printer, which will print the object.
And we are really trying to prepare them for the jobs that we don't know will exist in the future. And we know that 3D printing is going to change how we see this world. And we really want to allow our students to obviously know the tools. Of course, we're doing it at an educational level, but know the different processes that are involved in 3D printing, so that they do get excited, so that they do feel that, I graduated school and I do know how to use a 3D printer, so I can actually take that engineering course and take it to the next level because I have a base.
I liked the project because it was something different than we do usual in class.
I think the project was a lot of fun because also like at the beginning I was really struggling, and then we had like some like quizzes and like explanations from our teachers of what to do, and I found that a lot of fun.
I actually loved the whole procedure because it opens up a new world about 3D printing.
It was a nice experience for the students since they applied their maths knowledge, the knowledge for volume of 3D shapes, the area of 2D shapes, but also at the same time the surface area, how to convert the dimensions from centimeters to the actual millimeters, of symmetry and of rotational symmetry.
So what's amazing about projects like this is that it gives the opportunity to students to apply critical and computational thinking and combine skills, tools and knowledge from mathematics, computer science, engineering, art, and it allows them to build their ideas, their thoughts. It prepares them for the future.